solid state. Introduction. In nature, we come across rocky mountains, hills, icy glaciers, and sandy beaches, which all are solids. Rivers, lakes, seas, and oceans, which are all liquids. The atmosphere is made up of gases. However, solids are more common than liquids or gases. In the periodic table, there are 11 gaseous elements, few are liquids, and rest of the elements are solids. Hence, it is very important to learn about the structures and properties of solids. The properties of solids mainly depend on the nature of the constituent particles and the binding force acting between these constituent particles. The most important characteristic property of gases and liquid is fluidity. It means that gases and liquids have the ability to flow and are called fluids, whereas solids do not possess fluidity, instead they possess rigidity. Now the question is, why do liquids and gases possess fluidity whereas solids possess rigidity? The reason for fluidity of liquids and gases is due to the movement of constituent particles. In gaseous state and liquid state, the constituent particles are free to move about, whereas in solids, the constituent particles have fixed positions and can only oscillate about their mean positions, and hence they possess definite shapes and volumes, which is nothing but rigidity. Matter. We always classify the matter into three categories, such as solids, liquids, and gases. But whether a substance will exist as a solid or a liquid or a gas, that depends on the net effect of two main opposing factors. They are interparticle attractive forces and thermal energy. Now let us look into interparticle attractive forces. Interparticle attractive forces are the forces that always tend to keep the constituent particles such as atoms, ions, and molecules closer to each other. Now let us understand what is thermal energy. Thermal energy is the energy possessed by the constituent particles due to temperature. This thermal energy makes the constituent particle move freely, and it is directly proportional to temperature. Due to this, as temperature increases, thermal energy also increases, and hence the movement of constituent particle also increases. If interparticle attractive forces are very weak and thermal effects are predominant, then the substances will be in gaseous state. If interparticle attractive forces are slightly more than the effects of thermal energy, then the substances will exist as liquid. At low temperature, the thermal energy is low and intermolecular forces are so strong that the particles come closer, cling to one another, and hence they occupy fixed positions. At this state, the particles are unable to move from their fixed positions but can only oscillate about their mean positions. The substance here will be in the solid state. Classification of solids. Now, if you look at diamond and glass, we can see that both are solids. But if you look at them at microscopic level, we can see that there is a difference in arrangement of constituent particles. In diamond, the particles are arranged in an orderly fashion, whereas in glass, they are completely disorganized. Based on the order of arrangement of constituent particles, the solids are mainly classified into two types: crystalline solids and amorphous solids. Let us discuss about crystalline solid. In a crystalline solid, the constituent particles such as atoms or ions or molecules are regularly arranged in a definite pattern for a long range. Here, the arrangement is so regular that by just knowing the arrangement at any one site, we can very well predict the arrangement of other sites. In other words, there is a regular pattern of arrangement of particles which repeats itself periodically over the entire crystal. The examples of crystalline solids are sodium chloride, diamond, solid iodine, gold, quartz, etc. Now let us discuss about amorphous solids. The arrangement of particles in amorphous solids is not in an orderly fashion. Sometimes in amorphous solids, we can find few tiny orderly arranged portions in between non-orderly structures. Since they are very small in number, they cannot influence the overall structure. Due to this, the overall arrangement of the particles in the amorphous solids is distorted. The examples for amorphous solids are glass, rubber, and plastics, etc. Now, if we notice carefully the glass windows of very old historical buildings, we will observe that these glass panes are thicker at the bottom as compared to the top of the window. This is because as the time progressed, some of the molecules on the top of the glass flowed down due to gravity and accumulated in the bottom, making it thicker. Please note that this process is very slow and takes hundreds of years. Due to this ability of amorphous solids to flow like liquids, amorphous solids are also called as supercooled liquids or pseudosolids. Let's differentiate between crystalline and amorphous solids. The first difference is melting point. In crystalline solid, the arrangement of particles in every portion is same. Due to this, every portion of crystalline solid melt at same temperature. Therefore, crystalline solids have a sharp melting point. Whereas in amorphous solid, every portion of amorphous solid is different from its neighbor. Due to this, every portion will melt at different temperature. Therefore, amorphous solids melt over a wide range of temperature. The second difference is anisotropy and isotropy. Crystalline solids are anisotropic in nature. It means that physical properties are not same in all directions. If we consider this particular direction, the particles are all blue. If we consider this direction, we have alternate arrangement of red and blue. Now, if we consider this direction, the arrangement is again alternate, but the distance between them is more. Due to the difference in arrangement of particles in different directions, physical properties such as electrical resistance, refractive index, thermal expansion, etc. have different values when we measure in different directions. Whereas amorphous solids are isotropic in nature. It means that various physical properties are same in all the directions. If we consider any direction, the arrangement is completely irregular. Due to this, the physical properties like electrical resistance, refractive index, thermal expansion have negligible variation in different direction. Cleavage with a knife. When we cut crystalline solid with a sharp knife, we get a clean cleavage and smooth new surfaces. Whereas when we cut an amorphous solid with a knife, we get irregular surfaces.